Hi, I'm Dan Ridge, a program manager in DARPA's MTO, and it's a pleasure to be with you today. I'm at DARPA for about the last 2 years, but nobody's really from DARPA. We all bring the experiences of a career and a lifetime to us when we come to this job. And in my own career, I've done a lot of different things. I've worked in support of NASA, I've worked in support of the National Security Administration, and I've had the opportunity to do a lot of interesting things that sort of cross domains. And that's what I wanted to talk to you about today. So I'm going to talk about domain blending. So my background combines a lot of the things we see on the screen here: high-performance computing, media forensics, vulnerability analysis, and manufacturing and manufacturability. And what do these things all have in common? Well, for me, it means thinking about something that is familiar or even prosaic in a new way. How can we use it for some other purpose, or how can we identify a weakness in the existing process that we can shore up to make our country more safe? Obviously, each of these individually is a hard problem, and there's a lot of mission relevance for DARPA in each of these areas. But one of the things I've found over the course of my career is that some of the best problems lie at the edges. So here are some domains from my career, and one of the things that I found at DARPA is that we can take any one of those and we can run with it and make a 1 or 2 or even 3 order of magnitude improvement over the state of the art by pushing on it. But that many of the problems that are most interesting to me lie at the intersection of these domains. And so I've sketched a couple of out that indicate kind of things that I'm interested in. Not just individual activities, but new ecosystems that I think are possible. And so let me talk to you about a couple of these that we have here. If we, for instance, combine high-performance computing, an area of rapid and dramatic change over the course of my career, with semiconductor manufacturing, we may find that it's possible to move some of the acquisition process for high-performance computing into in situ and manage yield dynamically, right? So we may also find, by taking advantage not only of the computational power but the scale of HPC, that we have opportunities for topics like stochastic exploitation of hardware, where we're able to depend on latent defects that arise only at scale with commonality across them to identify manufacturing weaknesses. We can turn this around as we go around the circle and say, how about that scale? Can we use that for hardware accelerated vulnerability assessment to find new vulnerabilities and automate processes that are done in an artisanal fashion today? Continuing, we might say that that we have a responsibility to look at both sides of problems, even in areas where we make investments. So, for instance, memory-safe languages depend on the idea that memory itself is safe. But is that actually the case? And can we make progress there, both in defending American systems and understanding vulnerabilities that may exist in the global ecosystem? So those are some examples of problems that exist at the edge. And I'm interested to hear about new ideas for opportunities to combine these or other disciplines. The real question I have is, can I use X to solve Y in some non-obvious combination? So with that, thank you so much.